The universe is so big, my brain does a backflip just thinking about it. It's a scale that defies our everyday intuition, a vastness that's both terrifying and beautiful. Let's ground ourselves for a second. Right now, you're sitting on a rock, a beautiful, life-giving rock we call Earth. This rock is spinning at about 1,000 miles an hour, while simultaneously hurtling through space at 67,000 miles an hour in its orbit around our star, the Sun. And that entire solar system, our whole cosmic neighborhood, is circling the supermassive black hole at the center of our Milky Way galaxy at a blistering 500,000 miles per hour. But the ride doesn't stop there. Our Milky Way itself isn't stationary. It's drifting through a cosmic ocean, part of a local group of galaxies, which is in turn being pulled toward an even larger structure called the Great Attractor. And this ocean contains not thousands, not millions, but an estimated 2 trillion other galaxies, each one a city of stars, potentially with its own planets, its own stories. All this motion, this grand, silent ballet of cosmic forces, that's not a flex, that's just Tuesday in space. And it makes me wonder, in all this incomprehensible vastness, where is everybody? This question has a name: the Fermi Paradox. It's the profound, unnerving silence in a universe that should, by all statistical logic, be shouting with life. The math, at least on the surface, seems simple. In the 1960s, an astronomer named Frank Drake tried to formalize this. He created an equation, not to get a precise number, but to organize our ignorance. It's like a recipe for finding aliens. You start with the rate of star formation in our galaxy. Then you multiply by the fraction of those stars that have planets. Then the number of those planets that could actually support life. We're getting pretty good at estimating these first few ingredients. Thanks to telescopes like Kepler and TESS, we now know that planets are not the exception. They are the rule. There are likely more planets than stars in the Milky Way. Billions of them are rocky and orbiting in the habitable zone, that Goldilocks region where water could be liquid. But then the recipe gets tricky. What fraction of those habitable planets actually develop life? What fraction of that life becomes intelligent? And, the big one, what fraction of intelligent life develops technology that we could detect? And then, how long do those civilizations last? Here, our answers range from wildly optimistic to deeply pessimistic. And depending on your assumptions, the number of civilizations in our galaxy could be millions. Or it could be just one. Us. And so far, our cosmic DMs are empty. The phone isn't ringing. This leads us to a powerful and slightly terrifying concept: the Great Filter. The idea is that somewhere along the long evolutionary path from simple chemistry to a galaxy-spanning civilization, there is a barrier, a filter so difficult to overcome that it stops almost everyone. The critical question is, where is that filter? Is it behind us or is it ahead of us? If the filter is behind us, we might be the luckiest ones in the universe. Maybe the hardest step was the very first one, the jump from non-living chemistry to the first self-replicating cell. Maybe most potentially habitable worlds are just sterile, beautiful chemistry sets that never got the spark. Or maybe the filter was the leap to complex life, from single cells to multicellular organisms. It took nearly 3 billion years on Earth for that to happen. Perhaps on most worlds, life never gets past the microbial stage, leaving them as silent, slimy planets. If either of these are the Great Filter, then the silence in the universe is not a mystery, it's the norm. And we are the anomaly. But what if the filter is ahead of us? This is the more sobering possibility. It suggests that life and even intelligence might be common, but that something prevents civilizations from surviving long enough to go interstellar. Maybe intelligent species inevitably self-destruct through war, or exhaust their planet's resources and trigger irreversible climate change, or create a technology they can't control, like a runaway artificial intelligence. In this scenario, the sky is silent because it's a graveyard of civilizations that reached our stage. And no further. We could be racing toward that very same filter right now. That thought hits hard. But maybe the silence isn't about destruction. Maybe it's about choice. There are other, stranger possibilities. Consider the zoo hypothesis. What if advanced civilizations are out there, but they've agreed not to contact us? They observe us like we observe animals in a protected nature reserve, letting us evolve naturally without interference. We're not being ignored, we're being protected. Or there's the darker version, the dark forest hypothesis. In this scenario, the universe is like a dark forest at night. Everyone is silent, hiding, because you don't know if the other hunters are friendly or hostile. Announcing your presence is a potentially fatal risk, because any other civilization, fearing you might one day become a threat, would have a powerful incentive to eliminate you first. In this terrifying reality, the silence is a survival strategy. And then there's the simple matter of scale. Earth is 4.5 billion years old. The universe is nearly 3 times older. If a civilization got even a head start of 1 million years, which is nothing in cosmic time, they could be so advanced we wouldn't even recognize their existence. Their technology might be indistinguishable from physics, woven into the fabric of space-time. We might be like ants on a superhighway, trying to understand Wi-Fi. The cars are real, the signals are real, but they are so far beyond our comprehension that we don't even perceive them as technology. So, in the face of this cosmic silence, what are we doing? We're listening. For decades, projects like SETI, the search for extraterrestrial intelligence, have been scanning the skies, mostly for radio signals. Radio is a relatively simple way to send a message across the vast distances of space. We're looking for a signal that stands out from the cosmic noise, something structured, something artificial, a hello from the stars. But maybe they've moved past radio. We're also starting to look for other techno-signatures, powerful laser pulses used for communication or propulsion, the chemical signature of industrial pollutants in an exoplanet's atmosphere. Or we could look for the truly grand signs, astroengineering, megastructures like Dyson spheres, built to capture a star's entire energy output. Such an object would block the star's visible light, but radiate heat, glowing brightly in the infrared. We are scanning for these strange, dim stars. So far, nothing definitive. And we can't forget the sheer, crushing scale of time and distance. The speed of light, the universe's ultimate speed limit, means we're not looking at the universe as it is, but as it was. The light from our nearest neighboring star system, Proxima Centauri, takes 4 years to reach us. The light from the Andromeda Galaxy? 2.5 million years. A conversation would be impossible. We'd be shouting into a historical abyss. So where does that leave us, on our little rock, spinning in the great silent dark? It can feel lonely. But there's another path, another way to see our place in all this. What if the great filter really is behind us? What if the hardest part was just starting at all, and we already won the cosmic lottery? If that's true, then the silence isn't an omen. It's an opportunity. It means the universe is not a graveyard, but a garden, waiting to be tended. It means we might be the first to look up, to wonder, and to have the chance to reach out. If that's the case, then our job isn't just to listen for a message from the past. It's to become the message for the future. It's to last, to survive our technological adolescence, to overcome the filters that may lie ahead, and to become a mature, wise civilization. It's to spread, to carry the spark of life and consciousness from this one precious cradle out into the solar system, and one day, perhaps, to other stars. Not as conquerors, but as gardeners. And it's to become someone else's "we're not alone" moment. To be the signal that ends the silence for another young civilization, huddled around their star, wondering if they are the only ones. Tonight, when you look up at that impossible tapestry of stars, remember what you're seeing. Every star is a potential sunrise for a mind that hasn't opened its eyes yet. Every point of light is a promise. Until we hear a neighbor, I'm choosing to act like we're the message. A message of curiosity, of resilience, of hope. So be curious. Ask the big questions. Never stop learning about this incredible cosmos we are privileged to inhabit. Be kind to each other and to our planet. It's the only home we have, the vessel carrying our legacy through the void. Our survival depends on our stewardship. And build for the long haul. Think in generations, not quarters. Create things that last, ideas that endure, and a future that is worthy of the immense, silent potential of the universe. Because if the universe is listening, I want it to hear a story of a species that saw the vastness not as a void, but as a canvas. A species that looked into the great silence and chose to answer it with music. And if we truly are alone, then that responsibility is even greater. It's on us to fill the cosmos with meaning. It's on us to make it beautiful.